Hello everyone. In this video, we're gonna learn how to convert the quadratic function from the standard form to the vertex form, the vertex form to the intercept form, the intercept form to standard form. Alright, so the following are the standard forms, the vertex form, and the intercept form. Now let's take a look at the first symbol. For example, I have the standard form y equals 2s squared minus 4s minus 2, right? Now I need to convert this standard form to the vertex form and the intercept form, right? So I need to convert this one into vertex form first. So in order to do that, I need to factor 2 out, right? So I have 2 parentheses times s squared minus 2s minus 1, right? Now next one, I need to make this one as a complete square because I see complete square right here. Now I know that a squared minus 2ab plus b squared is going to be equal to a minus b altogether square. Alright, if you have the plus sign right here, and then this guy has the plus sign. Alright, so keep that in mind. So I look at this one right here. In order to make this one complete square, I need to add 1 and subtract 1. Alright, so it turns out to be 2 times s squared minus 2s plus 1. Subtract 1. And then I just rewrite negative 1 right here. Alright. The reason why, because I need a complete square. So in order to make a complete square, I need to have 3 terms right here. The first term, the second term, and the third term. Okay, this one is a squared. This one is negative 2 times a times b right here. If you don't see anything, you put 1, right? 2 times s times 1 times b squared. 1, which means 1 squared. Alright. And then I close parentheses. Alright, next one, I have 2 times the first 3 terms right here becomes a complete square, which means s minus 1 altogether square. Alright, and then this guy right here, negative 1 minus 1 is going to be negative 2. So you have 2 right here. You need to print it outside, right? So you need to distribute this one. So it turns out to be 2 times negative 2 is going to be negative 4 right here. So now we have the vertex form right here. Now a equals 2. Alright, h equals 1. K equals negative 4. The vertex is going to be 1, negative 4. The axis of symmetry is s equal to h, which means 1, right? So I'm going to graph this one using the vertex form, right? So the vertex is going to be 1, negative 4. S equal 1, y equal negative 4. It's going to be right here. This is my vertex. Alright, next one, I need to sketch the axis of symmetry. So axis of symmetry is going to be s equal to 1, so 1 right here. So s equal to 1 is the vertical line. Now keep in mind, the axis of symmetry is the line that split the graph into 2 halves. Alright. And then the next one, you need to find the y-intercept and s-intercept. In order to find y-intercept, I need to let s equal to 0, right? So you look at the standard form right here. The y-intercept, you just let s equal to 0, so y-intercept equals negative 2. So I know that any point on the parabola always symmetric about the axis of symmetry. So I automatically have the second point right here. right? Because this guy and this guy is symmetric about the axis of symmetry, right? Now I need to find the 0, right? So in order to find the 0, I just let y equal to 0, right? So this is y. I let this one equal to 0. So I have 0 equals to 2 times s minus 1 altogether square minus 4, right? Now I need to add 4 both sides, so it turns out to be 2 times s minus 1 altogether square equal to 4. And then I need to divide both sides by 2, so it could be s minus 1 altogether square equal to 2, right? And then I need to take square root both sides, right? So I have s minus 1 equals square root of 2, and s minus 1 equals negative square root of 2. Keep in mind, if you have s squared equals to a, and then when you solve this one, it turns out to be s equals plus and minus square root of a. Alright, so that's s in this situation, which means s minus 1. A in this situation, which means 2. Alright, so then I need to solve for s. So s equals root 2 plus 1. S equals negative root 2 plus 1. Now, root 2 approximately 1.4. So 1.4 plus 1 is going to be 2.4, right? So S equal 2.4 so it's close to 2.5, right? So it's going to be right here, right? And then S equals negative root 2 plus 1, which is negative 0.4, right? So this guy right here. So we just connect these points and we have the parabola. Now we need to convert the standard form to the intercept form, right? So after we solve the 0 right here, we use the 0 as the intercept form. Now we see that the intercept form is going to be a times s minus b times s minus q, right? So this is my p and this is my q, right? A equals 2 right here. It's never changed, right? This is the value of a from the standard form is the same thing as the value of a from the vertex form, and is the same thing as the value of a in the intercept form. So keep in mind, this value of a is never changed for three forms, right? Y equals s minus p, but p equals root 2 plus 1. So if you see two terms, you need to put parentheses. So you have root 2 plus 1. And then you close parentheses. Times s minus q. But q equals negative root 2 plus 1. And you close parentheses. Now you need to distribute the negative 1 right here. So it turns out to be s minus, you distribute this guy, you distribute this negative 1. So it turns out to be negative root 2 minus 1 times s plus root 2 minus 1. And this is the final answer for the intercept form. Alright, so let's move on to the next example. Now, given a vertex form y equals negative 2 times s minus 1 squared plus 3. Now, you have two different ways to convert this one into standard form. The first way, we're going to use the complete square formula. The second way, we're going to use the box method to expand this one. Alright, so look at this one. This is complete square. A minus b altogether square. A in this situation is s. B in this situation is 1. Alright, so I have a squared minus 2 times a times b plus b squared, right? So I use this formula to expand this one. It's going to be y equal to negative 2 times a squared, which means s squared, minus 2 times a which means s, b, which means 1. Keep in mind b is 1, b is not negative 1. Alright, so times 1 plus b squared, which means 1 squared. Okay, plus 3. Now I just simplify this one. Y equals negative 2 times s squared. Negative 2 times s times 1 is going to be negative 2s. 1 squared, which means 1 plus 3, right? And then I need to distribute negative 2, so it can be negative 2 times this, negative 2 times this, and negative 2 times this. So it's going to be negative 2s squared. Negative 2 times negative 2s is to be 4s. Negative 2 times 1 is going to be negative 2 plus 3. Alright, the final answer is y equals negative 2s squared plus 4s. Negative 2 plus 3 is going to be 1. So plus 1. This is the standard form. Now, the second way, we're going to use box method to explain this one. Alright, so if you couldn't memorize this formula, you can use box method, right? So, I have s minus 1 square can be written as s minus 1 times s minus 1, right? So I just put s right here and negative 1 right here for the first one. Now s minus 1, it should be right here. Alright, so s times s is going to be s squared. S times negative 1 is going to be negative s. Negative 1 times s is going to be negative s. Negative 1 times negative 1 is going to be 1, right? So I have s squared. Negative s plus negative s is going to be negative 2s. And then I have 1. It's exactly same thing right here. And then you just distribute negative 2, you get the answer right here. Alright. So, in order, now I need to graph this one using the vertex form, right? So my vertex is h and k, right? So which means 1 and 3, right? The vertex is going to be 1 and 3. Now a equals negative 2, less than 0. So the graph opens downwards, right? It's going to be like this. Now the axis of symmetry, s equal to 1, right? Because s equal to h, but h equal 1. So this is the axis of symmetry. Alright, so I have the vertex. I need to start the vertex 1, 3. So s equal to 1, y equal to 3. It's going to be right here. Alright, so from here I need to sketch the axis of symmetry. And you know that every single point on the parabola always symmetric about the axis of symmetry. So this is the axis of symmetry s equal to 1. Now this is the vertex 1, 3, right? Alright. Now I need to find the y-intercept, okay? So y-intercept, I just let s equal to 0, right? So I look at this one right here, let s equal to 0, and then y-intercept is 1, right? So let s equal to 0, well, this is my y-intercept. Alright, so if I have the y-intercept 1, I have the symmetric points, right? So the symmetric points, it should be right here, right? I don't need to calculate, I still have it. It should be 2, 1, right? And then the next step is to find the 0, right? So in order to find the 0 of this quadratic function, I need to let y equal to 0, right? So I have negative 2 times s minus 1 square plus 3 equal to 0, right? So I need to subtract 3 both sides. So I have negative 2 times s minus 1 altogether square equal to negative 3. Now I need to divide both sides by negative 2. So it's going to be s minus 1 altogether square equals 3.5, right? Now I need to take square root both sides, so it's going to be s minus 1 equals plus and minus square root of 3.5. Now I need to radicalize this one by multiply the top and bottom by root 2, right? So I have root 3 times root 2, it could be root 6. Now root 2 times root 2, it could be 2. So I have two different cases. The first case, s minus 1 equals root 6 over 2. The second case, s minus 1 equals negative root 6 over 2, right? So s equals root 6 over 2 at 1, right? And then s equals negative root 6 over 2 at 1, right? Alright. Now, root 6 approximately 2.45, right? And when you divide by 2, it should be about 1.22. Plus 1 is going to be 2.22, right? So, it's going to be somewhere right here. Alright. And then you know that if you have a point on the parabola, you should have the symmetrical point, right? So the symmetrical point should be somewhere right here, right? Now we just connect them. Now from this 2, 0 right here, we can write the quadratic function in intercept form, which is y equals a times s minus b times s minus q, right? So this is my p, this is my q, and then a is never changed, which is negative 2, right? So you just plug it in, y equals negative 2 times s minus parentheses root 6 over 2 plus 1 times s minus parentheses negative root 6 over 2 plus 1. Alright, and this is the intercept form. You can leave like this, you don't need to distribute it, right? Now let's move on to the last one. Given the intercept form, we need to convert back to vertex form and standard form. So for example, if we have y equals negative 3 times s plus 1 times s minus 5. Alright, so in order to convert it to standard form, it's very simple. You just use box method. You expand this guy. Alright, so I have s plus 1, I put s right here, 1 right here. S minus 5, I have s right here, negative 5 right here. Now I just multiply this guy out. So s times s is going to be s squared. S times 1 is going to be s. Negative 5 times s is going to be negative 5s. Negative 5 times 1 is going to be negative 5. Now I just add them up, right? So y equals negative 3 parentheses s squared, rewrite s squared. Negative 5s, add s is going to be negative 4s. And negative 5 right here, rewrite it. And you just distribute negative 3. So y equals negative 3 times s squared, negative 3 times negative 4s, and negative 3 times negative 5, right? So it's going to be negative 3s squared, negative 3 times negative 4 is going to be plus 12s. Negative 3 times negative 5 is going to be plus 15, right? And this is the standard form, so we're done with this one. Now, we need to convert this one into the vertex form. So, I need to rewrite the vertex form y equals negative 3 times s plus 1 times s minus 5. We know that if you given the intercept form, and then the axial symmetry is s equals p plus q divided by 2, right? in this situation, P is -1, right? Because you have the plus sign right here, the formula is subtraction sign. So I just write the plus sign as two negative signs, right? So this one can be written as y equals -3 times s. Right here, the plus sign becomes two negative sign, right? And then 1 right here times s minus 5, right? So in this situation, this is P, and this guy is Q, right? Look at the formula right here. Alright, so S equals P plus Q divided by 2, which is -1 plus 5 divided by 2. It's going to be 2, right? Now, this is the axial symmetries. The axial symmetry is actually the S value of the vertex, right? So in order to find the y value, I substitute s equal 2 back into the equation over here to solve for y, right? So y equals -3 times 2 plus 1 times 2 minus 5, right? So it's going to be -3. 2 plus 1 is going to be 3. 2 minus 5 is going to be -3. So when you multiply this one out, it turns out to be 27, right? So the vertex is 2, 27, right? So I use the formula right here. Alright, so my answer must be y equals, now a always stay the same, right? A equals -3, so we don't change this one. So it should be -3 parenthesis s minus h. This is h. This is k. So h equals 2. So I put 2 over here. Square, right? Plus k. K equals 27. So it's going to be right here. And this is the answer for the vertex form, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals, they take us higher. The night's young and it's just begun as she puts her hand in mine.